Welcome everybody to the future of carbon removal. We're so glad that you are here with us for today's conversation. My name is Susie Spiegelman. I'm Director of Partnerships at Clean Energy Trust. For those of you who are new to CET at the very highest level, we invested and support emerging climate technology startups from across the greater Midwest region of the United States. Additionally, we host a variety of events and programming throughout the year meant to build up the climate tech ecosystem, welcoming folks like you to learn about the industry, support our mission, and help scale emerging climate technologies. Before we get things started, we want to quickly acknowledge all of our fantastic members and supporters who keep us going. We're so grateful to all of you. You're the reason that we're here, and you empower us to do the meaningful work that we do. If you aren't a member, and you would like to be, or if you would just like to get involved with the work that we do, we'd love to hear from you. Our marketing communications manager, Amy Yano Fairbanks, will drop our contact information into the chat in just a minute. Feel free to reach out to us at any time. So today's conversation will be led by CET's Managing Director, Paul Seidler. He'll kick things off with a quick introduction, followed by a group discussion with our panelists. At the end, I will be back for audience Q&A. So as you think of questions during the session, please pop them into the Q&A window in your Zoom screen. And then finally, at the end of the session, we're going to give you a sneak peek of our next webinar that's coming up in June. So be sure to stick around for the details on that and sign up. So with all of that out of the way, I'm going to turn things over to our speakers for some brief introductions, and then Paul's going to take it from there. Freya, do you want to kick things off with your introduction, and then we can jump to Deepika and then Jim?
Thanks, Susie. Yes, hello everybody. My name's Freya Burton. I'm the Chief Sustainability Officer of LanzaTech. We're a company headquartered here in the Chicagoland area. Our technology is carbon recycling. We essentially have developed a biological platform to take waste carbon in the form of emissions from industry or solid carbon that's been turned into a gas stream and essentially convert it biologically into fuels and chemicals using a process called gas fermentation. So that's what we do. We're all about keeping carbon in the material cycle, and very pleased to be here for the discussion today.
So if I'm next, hi everybody, thanks for being here, and thank you to Clean Energy Trust for having me. My name is Deepika Nagabhushan. I'm the program director for the carbon capture program at the Clean Air Task Force. The Clean Air Task Force is a 25-year-old nonprofit, and we are a climate nonprofit, and we work internationally within the US as well as in the EU and several other countries in Latin America and in Asia. And my role basically is policy development, policy research, and supporting the scale up of carbon capture, removal, utilization, and storage of CO2, sort of supporting the industry, developing a policy roadmap and working on implementing those policies with the help of a coalition at the federal level as well as the regional level. My current focus is regional storage. So I'd love to talk about that and how that connects with carbon removal and the prospects of the industry. So with that, I'll stop, and very happy to be here.
So I think it's my turn. So Jim McDermott, I'm with Rusheen Capital Management. It's a firm that I run, private equity firm. Prior to that, I ran a group called US Renewables Group for about 16 years. Main focus has been on low carbon activities across the spectrum, energy, fuels, infrastructure. These days, I'm actually a board member at Carbon Engineering, which is a direct air capture company focused exclusively on extracting CO2 from the atmosphere. And I also do a lot of work in conjunction with Occidental Petroleum through a vehicle called 1.5, which is effectively a development platform for taking Carbon Engineering's technology and scaling it to start building projects. You know, whereas I used to be, I joke, I used to be sort of very involved in Clean Tech 1.0. Now I'm doing only carbon and hydrogen. But looking forward to talking today, and thank you, CET, for inviting me.
Great, thanks, Jim. And that was just your clean tech resume, but you had some you have some experience back in the .com tech days as well.
Yes, the joke in California is that I came out here to do energy related stuff from New York, and the joke in California is if you can't find a job, start a software company, which I did while I was in graduate school. And if you've ever been harassed by the stamps.com people, that was a company that I started when I was unemployed in grad school. So if you're ever on Spotify and they're bothering you, I'm sorry.
Awesome. Thanks, Jim. Thank you, Freya. Thank you, Deepika. Thank you, Jim, so much for joining us today. And thank you, everyone who registered. We had nearly 500 folks register for today. Clearly a lot of interest in this topic. My name is Paul Seidler, Managing Director at Clean Energy Trust. I oversee our investment process and portfolio management, as well as webinars on different elements of the periodic table. We did hydrogen last month, carbon today. Not sure which one is up next, but these are very interesting topics today with a lot of momentum. So before we dive in with the panelists, I want to show you a few pictures, a few numbers, a couple words, and just to set the table for today. So Susie, if we can jump to a first slide, that would be great. So think of a boat as the atmosphere, and if the boat has a leak, the water is carbon dioxide flooding the boat. We need to fix the leak in the boat, but that won't be enough. We can't just stop the emissions of CO2 into the atmosphere. We have to deal with the emissions that are already there. You can't just fix the leak in the boat. You're going to have to bail it out too if you're going to survive. So this is a really interesting topic because it also is a very daunting topic. So think about this analogy sort of as we go through the discussion today. A number on the next slide that I want to share is the current concentration of CO2 in the atmosphere being 415 parts per million. This is well above what is considered the safe level. On the next slide, you will see the sort of steady increase, really increasing rate of concentration of CO2 in the atmosphere over the past 4 or 5 decades. It's gone from, the safe zone is arguably, well, it's no one really knows, but it's somewhere between 300 and 350, 350 really being the absolute max. What we're at today is just way overboard, and we need to find a way to bring it back down to safe levels. The problem is, on the next slide, the leak of CO2 into the atmosphere is just enormous. In 2019, we were just a touch above 50 gigatons of CO2 equivalent being emitted into the atmosphere. In 2020, a global pandemic hit. We never saw it coming, and it virtually brought the entire global economy to a halt. As a result, on the next slide, you'll see that in 2020, the effect it had was only reducing emissions by about 5%. So when you think about that, and honestly, when we were the panelists, we were just chatting before we started how none of us have really been on airplanes in over a year. It's been the most amount of time in our entire lives that we haven't taken a plane trip, and it's kind of shocking to think about, how reduced travel has been among many other things, yet the emissions are still so extraordinary. So it's a daunting challenge ahead of us. On the next slide, the sources, it's well beyond transportation and the electric sector. We're making good progress in electricity, in renewables, as well as converting the early days of converting transportation to EVs, but we're not going to be able to necessarily electrify everything in transportation, and it's going to take a very long time to convert the power grid to fully decarbonize renewables and or nuclear. So we have a long way to go. So in talking about carbon removal today, there's lots of sort of code words. I want to make sure we're all on the same page. We've heard CCS and CCUS in the past, referring to carbon capture and storage, or carbon capture and utilization and storage. There are a few new ones that have really popped in the last year or two. CDR, carbon dioxide removal, is really referring to atmospheric emissions and removing those, whether it's through new technology or nature-based solutions. DAC, or DAC, direct air capture, is on that technology side of CDR, using new technological systems to extract CO2 from the atmosphere. And then just talking about gigatons of CO2e, what does that mean? We're talking about gigatons of carbon dioxide equivalent, which includes other types of emissions. A gigaton is a billion metric tons. A metric ton is a kilogram. So when you see GTCO2e, we're talking about 1 trillion kilograms of CO2 equivalent. On the next slide, just so that we're all on the same page in terms of point source emissions and atmospheric emissions. The point source emissions are the new emissions. They are coming from the leak in the boat. The atmospheric or legacy emissions, that's the water in the boat that we have to bail out. And then finally, the agenda for today, we want to lean on sort of the three-legged stool framework of technology, markets, and policy. The first section will really dig into technology, and then we will dig in a little more on markets and policy sort of at the same time, because in this case, they really are extremely intertwined. And then we'll round out with a very quick lightning round of are you long or short on a few different interesting topics. So with that, we can take the slides down so that we are regular sized Zoom heads and dig in. Deepika, I would love if you could sort of build on that very basic introduction in terms of where we are today with point source emissions, carbon capture technologies for point source emissions, as well as some of these new technologies that are out there, just at a high level, help sort of set the table.
Yeah, of course. Thanks. So you already identified the various types of carbon capture that we're going to be discussing, and thanks to Susie for putting it in the chat as well. With respect to carbon capture at a point source, typically what we've seen is that we started to do carbon capture in natural gas processing to begin with, in like about a few decades ago. So that's one. So it's an industrial application to begin with. Then we started also seeing carbon capture application on in the power sector, on coal-fired power plants. And we saw that happen at Boundary Dam, which is in Canada. And we also saw a project in the US that is currently mothballed for economic reasons. But we've learned a lot, I think, in the past with these examples and these projects, what's working, what's not working. Specifically, what I want to highlight is that we have learned that the technology works. Carbon capture works as a mitigation tool on point source, whether it's power, whether it's industrial sources. There are definitely applications of CCS we have not yet done at large scale. For instance, where we will mostly need it would be cement, would be steel, would also be potentially natural gas fired power plants, and potentially a role for CCS in creation of zero carbon hydrogen when applied on steam methane reformation. And this is all, I would say, in the point source category. Cement, steel are kind of in the works. And we don't really have big demonstrations yet at a commercial scale. But we also have direct air capture and other carbon dioxide removal. So direct air capture, we've seen a few, and I know that the other panelists on the panel here can speak more to it as well. But direct air capture, we don't have a large scale project yet. We are yet to see a large scale demonstration of it. There are some technologies that are suited for large scale, some technologies that are suited for smaller modular scale. The ones that are modular, we've seen about, I would say, a dozen or less pilot plants, which are really small, like 1 ton a day or something to that effect. So very, very small scale. We have got a long way to go to really reach scale. And I'm going to talk a lot about scale because I am the nonprofit here. My job is to think about how do we solve the climate change problem and how do we move the needle on emissions. So scale is very important to me, and it's a very important lens through which we evaluate a lot of our policy work. So yeah, I think that there's a long way we have to go. I think that we've seen some policy movement in the new administration in the US, a lot of interest in Europe, in Netherlands recently, and in Norway. All of these countries are really working hard to sort of expand the application of CCS in all of these industrial applications like cement and steel and other industrial sources. So yeah, I think that I would just want to stop there and say that we've got a long way to go. And these are all the applications that are all important. We not only need to mitigate and reduce emissions from these sectors, we also have to remove and go negative. Without both of these together, we won't be able to meet our climate targets by 2050.
Thanks, Deepika. Does anyone on the panel have a sense of the cost per ton for point source capture? Deepika, you mentioned a couple projects that are operational, and obviously we have a long way to go with some of the harder to electrify emission sources like concrete, steel, hydrogen, et cetera. But does anyone have a rough cost per ton for that solution?
It depends, right? It's I mean, like amine stripping, which is basically what you do on a power plant, tends to run. I mean, I'd say it probably runs between like 60 and $30 a ton if you're at 7% concentration.
Got it.
Thereabouts. Like Savante, the guys at Savante are, I think, I mean, again, I don't know exactly where they are, but they're sort of saying they think they can do 35, I think 35, 40, like that.
I would peg it at a little bit higher than that. I think that there might be differences in sort of the first of a kind versus the nth of a kind. Sometimes companies do quote the nth of a kind costs. I think that there are definitely lots of factors to take into consideration. Scale is one. Concentration, like Jim mentioned, very much a big portion of how cost is determined. I think with currently, I would say something like $75 a ton for like a natural gas-fired power plant, or like $60 to $80 a ton for a coal-fired power plant. It also depends how far they are from storage, and whether or not transportation is going to be a hindrance or a cost barrier. Direct air capture definitely features on the top of the spectrum because it's capturing from the most dilute source, like you pointed out, 415 ppm. That's what we're working with. It's a super dilute source of CO2, so I guess it's harder. So yeah, I would say that definitely depends, like Jim said, and the ranges kind of are above, I would say, the 75 range.
Okay, so
I would probably add here, Paul, and this is sort of putting on the utilization hat, that if you are doing point source and making stuff and making money, this makes a big difference. And that's, I use LanzaTech as an example because here, we can sort of retrofit into a steel mill, for example. And we always joke it's like putting a microbrewery into a steel mill because we're fermenting the gas. And instead of making beer, we're making fuels and chemicals that can be sold. So then you've turned carbon into that, from that liability and even a cost liability beyond the atmospheric one, into an opportunity. And then you're putting carbon into either into the fuel pool and keeping fresh fossil in the ground, or putting carbon into the material cycle if you're making chemicals that can go into products. So in a way, you're sequestering it into stuff instead of the ground, and you're making money on it. So that really sort of changes the story a little bit when you're looking at alternatives to those traditional point source applications.
And with some of those industrial sources with point source capture, whether it's steel or cement or something else, are there different challenges with capturing the CO2 when there are both process emissions and energy emissions?
Well, I'd say the biggest challenge is when you're capturing CO2, you're going to need energy. because there's no energy there. And in the steel mill, the gases that we use, and that somebody's put in the chat, we're taking carbon monoxide, which would otherwise then be flared or combusted for heat and power as CO2. So it's a sort of CO2 mitigation technology using our process. However, if we're going to use CO2, you need that energy source, which can come in that form of a sustainably sourced hydrogen. That's where, you know, the pathway comes. I mean, ultimately, as we look at that and direct air capture and so on, for all these CO2 technologies, the biggest challenge is, where is your clean source of hydrogen, low cost and clean source of hydrogen going to come from?
Great. Okay, so let's move on to CDR and addressing atmospheric emissions. It feels like it's getting to a point where people are seeming to agree that if we're going to get to net zero by, say, 2050, it's going to require some element of CDR capturing some emissions from the atmosphere. So one type of CDR is DAC, and this is starting to get more traction. Jim, we'd love to hear about what you're working on in direct air capture.
Sure. So it's actually interesting looking at your chart. I mean, one of the reasons that we, or my partners and I, and me personally, think that DAC is going to essentially be central to what goes on going forward, is that if you look at that and you say you have 3 ppm and we're at 415, the math we did 6 years ago was, well, if I got to get down to 280, effectively, you know, 98% of the problem is already in the atmosphere and 2% of the problem is emanating from existing businesses. And so when you look at that and then you look at capital flows, right, it's completely inverted, right? We're spending all of our money at this point on the 2% when we should be spending on the 98. So when we look at that as investors, we're like, arithmetically, it's going to have to flip flop if we're going to have a shot. I think the thing about DAC that I think is widely misunderstood is that there's lots of numbers running around out there, but I'm deep in the weeds with Oxy and a bunch of other, you know, engineering firms to develop build a plant that's going to be 500 kilotons in West Texas, and it's going to be CO2 out of the atmosphere using, you know, 0 carbon electrons off the grid, off of ERCOT West, right? So probably one of the biggest things about these technologies is that they're very electrically intensive. They're water and electrically intensive, and so the price of electricity plays an enormous role. So every day that we see cheaper and cheaper wind and solar is a day that DAC becomes more and more cost effective and efficient. I think our belief is that in order to hit the 50 gigatons that we're going to need to be, or the 10 gigatons that IPCC thinks we're going to need to be taking out by mid-century, that we need, you know, it needs to be $100 a ton or lower. I think based on the engineering that we've done to date, we think, and again, this is based on, there's a thing called Wright's Law. Wright's Law basically, Wright's Law is the precursor to Moore's Law, which I'm sure people are probably more familiar with, which is basically the doubling of clock speed in a microchip connotes a reduction in half. Wright's Law basically says if you move from, you know, kind of a base point, every time you double unit output, comes down between 6 and 7%, and then becomes asymptotic at about 60%. Given where we are today, with carbon engineering and with 1.5, we think that there's a very legitimate shot to hit kind of between 130 and $100 a ton by 2030. And that's based on bottoms up engineering. That's not people talking about it. That's engaging it. So I think, you know, I think one of the big misconceptions out there's a lot of numbers that get thrown out, like it's $1,000 a ton. It's nowhere near that. It's considerably cheaper today. And as the engineering cycles start to kick in and you get that Wright's Law effect, we think that over the next decade, it can easily come down to, you know, $150 a ton, which again is expensive relative to some other things. But I think one of the things that a lot of people, I hope people take away from this, is that when you think about direct air capture and permanence of sequestration, I mean, when you think about CO2 sequestration, removing it, you have to think about along 3 axes. You have to think along price, speed, and permanence, right? Because simply being cheap but not being permanent is not very useful. Being very, very cheap and being permanent but being extremely slow doesn't work either. And I think a lot of the confusion that gets brought into these conversations is often that people aren't thinking along. It's a three, think of it as X, Y, and Z from an axis perspective. You got to hit on all three of those to make direct air capture viable. And we're moving in that direction, but it's early days. I mean, and a lot of cost is going to have to come out.
Okay, well, I was gonna dig into this topic a little bit later in the conversation, but it feels like now is the time. So, in pricing carbon, then how do we think about permanence and some of these other factors? Like, should we? I guess, Deepika, I'll look to you. What's the most effective pricing policy? Is it a universal policy, or should we be distinguishing between point source and atmospheric? Should we be distinguishing between the permanence and other factors like land use?
Right. I think that there's two ways to look at it, and the way that Clean Air Task Force looks at it is, I think we first are thinking of it as a technology innovation problem. And then we're thinking about the role of climate legislation, such as a economy-wide common number carbon price, as something that layers on top of it once you've leveled the playing field to a large extent with technology innovation policies. So right now for carbon capture, whether it's point source or whether it's direct air capture or bioenergy carbon capture, we're looking at it from a the technological innovation point of view. So we see that there are other tools than carbon price, because if it was the carbon price, the EU ETS system should have solved all the problems, and that was not done. That did not happen, right? We see that there's a lot of lessons to be learned from Europe when you look at the role of ETS over there. So which is why I think that things like 45Q, which CATF helped, was one of the pioneering organizations to do the analysis for the need for 45Q, and we continue to work towards advancing what that tax credit can do, in terms of changing it to direct pay and getting it at a higher level, and specifically one for direct air capture, sort of adding a new level. So, what we think right now is that there needs to be support for innovation in terms of R&D, and there needs to be support from the government in terms of getting commercial demonstrations, not just one of a kind. Like what Jim was talking about, the learning curve is, I think, what you were referring to when you were talking about Wright's law. You need to walk down the learning curve in the initial stages. So you want to get to the first of a kind, go all the way to maybe third to fifth of a kind. And in fact, that is what we're advocating for right now, that DOE does. The DOE supports using their budgets, commercial demonstration of fifth of a kind. At that point is when we believe that the technology, and in addition, we also think that there needs to be deployment incentives like 45Q, which are updated to match the dynamics in the market. And the fourth piece is to have the infrastructure. We definitely need the government to step in to create transportation and storage infrastructure that can be enabling these capture projects to go on. So once these four pieces of R&D, commercial demonstration, deployment incentives, and infrastructure are in place, we believe that it would be the right time for carbon price and tools that are more economy-wide, like clean energy standard or low carbon fuel standards. These are slightly more broader and more, I would say, they don't necessarily might have carve outs for different technologies for those kinds of economy-wide policies to then really impact wide scale deployment, because that's the job that they have to do. Those policies are meant to do rapid penetration and rapid deployment of these technologies. But unless the timing is right and we've done all the four things up front for these technologies, the wide scale deployment would not take place, even if you did, because then it'll be confusing as to like what would be the right price. Well, but I think if you've helped these technologies come down a learning curve, and we're seeing all these technologies around that $100, $150 a mark, then you kind of have a good understanding of how these policies might play, and it becomes more politically easier and clearer to even implement it. So I think we believe that getting innovation policies in place is a way to get to a point where carbon pricing is politically feasible.
So you're arguing to keep it simple, but do what we can to buy down the cost curve across various technologies.
We do need to specifically target each type of technology and make sure that they've got targeted policies to support the innovation required.
Okay. In the absence of a carbon price today, for the most part, who are the buyers of some of these projects that are being developed? Jim, who's buying your CO2?
Well, look, there's a couple people. I mean, if you really look at, and I know that this, for a lot of folks who are on the sort of the more green end of things, they find it sometimes offensive. But the bottom line is that the biggest consumers and the most knowledgeable people in the world around CO2 are oil companies. CO2 for EOR is an enormous business in the United States, and the folks who manage it, move it, put it subsurface are all oil companies. They buy. That's a function of West Texas Intermediate. So there's a pretty well-known function that basically rides with that. I think increasingly what you're seeing with direct air capture and things like that is that you're seeing, particularly good, like airlines are a good example, right? Airlines they emit such large sums of CO2 that they're realizing that if they're really going to decarbonize, that what they're going to end up having to do is effectively buy entire output from direct air capture plants. And that is something that we're seeing people, and 18 months ago, nobody was even willing to talk about that. Now there are many conversations with airlines all over the world. So I think what you're going to see is you're going to see corporations doing it who've made net zero pledges. And I think the other really interesting innovation that's coming out of that is that you're starting to see the green bond market starting to respond to that. So like, as an example, let's say you're UPS, right? And I'm just picking them because they're a big, they fly a lot. They're a AA rated credit. They can issue a green bond at 3%. And I wouldn't be surprised if you see effectively deals done in the not too distant future where a large corporate issues off their balance sheet and effectively finances the plant, and it gets run like a tolling operation, right? Which is the exact way we run commodities, right? Which is, somebody owns the asset, and the farmer comes through, and there's just a tolling charge on the processing. We think that that's a very viable model. But the blunt reality is that in straight sequestration right now, the only people that are actually putting things subsurface and keeping them permanently right now are oil companies, EOR. Now, the fascinating thing about that is that you just heard that one of the reasons that the Section 45 tax credit is so innovative and exciting is it's effectively putting something in place that allows the oil companies to start to transition from oil companies to carbon management companies. And it's saying, look, if you're willing to do this on a straight sequestration basis, we're going to show you a pathway to make that profitable. So you can not do EOR, you can be a straight sequestration entity. And that's an enormous thing, because it turns a large section of the economy, the oil companies, from somebody who might in past has been resistant to someone who's like, hey, wait, there's economic incentive in this for us now. So let's take the technology, let's innovate, let's make the capital investment so that we can be a leader in that emerging business, rather than resisting the sort of the more punishment-based system.
Great. So for folks in the audience, just to make sure we're all following EOR, we'll add that to the glossary of terms.
It stands for Enhanced Oil Recovery. Right. It's a process whereby you take CO2 from the atmosphere and you use it, you pressurize it and you push it subsurface in order to keep the hydrostatic pressure in the field at a constant rate. So think of it as like a sort of like a big, there's a lot of oil, and as it depletes, if you push down CO2, it gets the oil to rise. So it's a way to continue to utilize older oil fields. And again, I think there's a lot of resistance, and I think rightfully so. There's some questioning about, well, if we're taking CO2 out of the atmosphere and putting it into an enhanced oil recovery field, aren't we just producing more oil? I think that as long as we're still using oil, decarbonizing it at the wellhead is a great business to be in. But there is clearly a drive that's accelerating to just say, I'd like to take my CO2 out of the atmosphere and put it into a field that isn't producing oil, which is known as just straight sequestration. And I personally believe that's going to be just a gigantic business, just enormous.
So, okay, aside then from Freya, I want to bring you in, aside from just EOR or straight sequestration of CO2, what else can we do with CO2 where perhaps it's not just a cost center, but also converted into a value of good, or a good of value?
I think it's funny because you see sometimes oil companies talk about just look around you, you need oil for everything. But we think about it as look around you, look at where all this carbon is. And the question is, where does your carbon come from? So carbon is in all parts of our lives. And now we've got this opportunity to think about where the carbon comes from. Is it fresh fossil carbon taken from the ground? Or is it something that's recycled carbon? So there's no single-use carbon anymore. You're giving it another lease of life. And sometimes if you're making a durable good that could then go back into the recycling pool, as I mentioned, sort of like what LanzaTech does, you're locking that carbon into this, what we call the new carbon economy, or the new circular carbon economy. So keeping carbon in the material cycle. So, what can you make? Well, just using LanzaTech as an example, fuel, you can make ethanol. We can also upgrade that ethanol to a sustainable aviation fuel. And in both cases, while yes, it's combusted as a fuel, if we're using that while we're transitioning to, electrifying the road transport, and while we're looking at new technologies for aviation, by doing that, you can displace fresh fossil for those sectors. So overall, it's better for the environment. What else can you do with ethanol? Well, you can use it in, your household cleaners. There's ethanol there. Perfume, there's ethanol there. You can convert ethanol into PET. So you're looking at packaging. So in your kitchen, just open the fridge, open your cupboards and fridge. There's carbon everywhere, or fossil carbon today. And so you can convert this atmospheric or point source carbon into these products. Clothing is another thing. So, I think the textile industry is hugely overlooked in terms of its carbon footprint, and PET is probably the most common one we think about, but thinking of synthetic fibers, sneakers, it's a lot of workout gear people have been wearing the last 12 months at home. That's all carbon. So really, it's you can use that carbon to make pretty much everything in your lives. And I think what's important is to start thinking about where that carbon's come from. A bit like you might think about organic produce or fair trade goods, or FSC certified paper goods. Start thinking about the carbon, and you name it. If it's got carbon in it, you can get it from a previously used carbon. I just saw somebody in the chat. I do like the idea of the vodka and ethanol perfume. Just watch this space.
And for anyone on the panel, what other technologies are being developed for CDR beyond DAC and trees? What is in between that maybe is just really at the beginning of R&D?
Can I, Paul, if you don't mind, could I add to what Freya was talking about on utilization markets just before we get into your next question?
Sure thing.
I just want to also add that, typically in the climate policy circles, we'll talk about emissions. We'll talk a lot about emissions. It's all we talk about. So we talk about the combination of mitigation technologies, such as carbon capture on point sources, clubbed or combined with carbon removal, like direct air capture, to reach net zero. But the truth is, it has to be more interesting than that. Like, I think with carbon removal and utilization markets, like what Freya was talking about, I think this goes beyond emissions. We have to create a robust carbon management industry, or a carbon utilization industry, which is part of the carbon management industry, that can survive 2050. The world is not going to end in 2050. So, all of our infrastructure that we've built needs to continue to have a robust market going into the future. So I think, while I love to talk about scale and while I love to talk about emissions, I also want to highlight the fact that we, from a policy perspective, it's very important to also encourage a utilization market that can survive without sort of emissions being the main purpose, because that is sort of this cycle that we need to continue on beyond, after when we meet our climate goals from an emission standpoint. So that's an important, I just wanted to sort of say that as an addition.
Great.
Sorry, back to your question on other technologies.
Yeah. Is anyone sort of following some of these taking technology and adding it or expanding on nature-based solutions to improve them or utilize them at scale. The benefit of nature-based solutions is their sort of cost at scale, but of course there are challenges with, I don't know, what is the metric when you're comparing, say, DAC to trees, like carbon capture density? Like, what's the metric that where we see challenges with nature-based solutions?
I'll give you we actually did this calculation. We're using it in having some discussions with people. If you look at like a reference plant, a carbon engineering plant, which they're on record as announcing a 1 million ton per year facility, it takes up about 100 acres. So think of it as 10,000 tons per acre. The same equivalent trees is about 2.7. So you've got, there's, or said another way, because it's always a little hard sometimes to grasp those types of numbers, that if you wanted to reach the 10 gigatons by 2050 using DAC plants, you'd need 10,000 DAC plants at 100 acres. You'd need to basically do 3 times the United States in terms of surface area. This is one of the, it's one of these things about, I'm very much in the camp of, again, speed, cost, and and permanence. One of the other problems that, and again, I'm not saying that I personally think that nature-based solutions should be utilized as fast as humanly possible. I don't believe from a quantitative perspective we have any chance if that's the sole focus, right? It'll never get there. But there are people, like the Gates people were doing some really interesting stuff. I don't know anything about the Rice Foundation or the Rice Project, where they were basically taking C4 and C4 and C3 photosynthesis and trying to basically get trees to, there's like a lot of stuff in sort of biology-based stuff where they're trying to sort of get plants to do stuff. But I actually think that one of the most interesting areas in DAC is people talking about using effectively the surface of the ocean as effectively a membrane, right? And sort of accelerating the carbon cycle by changing the pH. I personally, there's a guy actually at UCLA, a guy named Grav Sant, who runs it's the Center for Carbon Management, who's doing some really innovative stuff along those lines. But the idea of effectively, think of it as the surface of the ocean is a gigantic membrane that's pulling CO2 down every day, every moment. Is there a way that we can engineer that so that the uptake rates are faster? I actually think that's an innovative and interesting area of exploration.
That does sound interesting. Maybe a little scary too. Anyone? Well, actually, let's move to one other question before we move to the lightning round. But on policy and markets, I want to make sure we touch on this. What are we seeing from the Biden administration in the jobs plan? Deepika, I think you've been taking a close look at this.
Yeah, I can speak to you a little bit of that. Like the Energy Act of 2020 that was passed last year, like late last year, maybe December of 2020, we saw specific call outs for carbon removal, both R&D, test centers, demonstration support. And I think that there was a lot of authorizations. There were no appropriations. So we're now in the stage of getting Congress to appropriate those things. So, I feel like there's a lot of, legislation that's already been introduced, both in the Senate and in the House, that are, pushing a higher level 45Q for deployment. And at the same time, there are R&D focused bills that are in the making that are hoping to sort of appropriate some of the money that was authorized in the Energy Act of 2020, getting, a couple of $1 billion for commercial demonstrations for carbon removal and additional money for R&D. So there's innovation for additional technologies like the ones you were talking about. I think ocean capture is part of that mix there. So there's a lot of interest. And I do have to say that the Biden American Jobs Plan that was recently released specifically calls out what is called the SCALE Act. And the SCALE Act is basically supporting through grant money, development of storage sites and transport infrastructure for carbon capture. Now, while I understand the 1.5 project that Jim is leading is very close to where the storage might be. And in this case, it's EOR in Texas. There's going to be a need for saline storage development to support, large, I would say, clusters of projects where direct air capture might also be one of the candidates of, a project that sends its CO2 into a pipeline system that all goes to one storage site. So, one storage site would be like 10 million tons a year sort of capacity. So it doesn't have to only be reliant on one single source. It's sort of reliant on, it's a bit sort of a de-risked business model where you have 10 sources sending you CO2. So if one sends in a little bit less and the other person sends in a little bit more, you're still able to store 10 million tons a year. So that's a really interesting business model that's coming up in the Midwest. Given Clean Energy Trust is in Chicago, Midwest seems to be an important thing to bring up. I personally think that there's going to be a lot of activity in the Midwest specifically because there is excellent geology there for storage and a lot of capacity, more than I would say anywhere, I guess, following Permian, the Permian Basin in Texas area. So yeah, I think the Biden administration is very, very focused on supporting both the capture side as well as the ecosystem on the transport and storage side, which I think are all great indications of support and development that we can see in the carbon capture or sort of carbon removal space, specifically in the direct air capture space.
And if I might add to that, it's worth mentioning that the Department of Energy and other sort of departments within in the US here have been incredibly supportive for innovation in the sort of carbon capture, utilization, circularity, and so on, which we've seen with a number of the sort of initiatives that have come out, even in the last sort of 12 to 18 months. And, as a company that has, we have a footprint globally, it's been really telling to see the leadership in, especially from the Department of Energy, and we've worked closely with them for a number of years in this space, and actually watching it over the years sort of build more of these technology, I suppose, frameworks within funding scopes and so on. And I think Deepika mentioned it earlier, the importance of things like loan guarantees and government grants to help de-risk getting these technologies, sort of getting that first foot on the ladder or getting to scale. And the US is by far and away one of the leaders in this very specific way.
Great, thank you. So with just a couple minutes before we move to the audience Q&A, we're going to do our lightning round. Are you long or short on a few different topics? Are you a buyer or a seller? Freya, I'm going to throw it right back to you on the first one. Trees, which we touched on briefly, but trees for carbon dioxide removal. Are you long or short?
Yeah, it's all good, just not exclusive, I would say.
All right, Deepika.
Yeah, I think I'm going to follow Freya on this one. I don't think that there's any technology we can leave on the table. We don't have that privilege today. 30 years from 2050, we do not have that privilege. But I think that it's important to think about the scale of each of these technologies and sort of the accounting issues like permanence with trees. So yeah, I would be cautious. I would be cautious in putting my money in trees. Because recently there was a study that was released in California that identified about 39 million tons of CO2 were credits using forestry were sort of invalid. So there are some issues. It's not that trees are not good. We definitely need to preserve a lot of the green cover. There's just accounting issues that we need to resolve.
You can be short on trees for CDR, but still love trees. I don't want to mix messaging here. Jim, are you long or short on trees for CDR?
I'd say I'm on CDR. I'd say I'm short, but I'm long trees. They're necessary but insufficient.
And beautiful, yes. I guess maybe we could all agree that we should protect the existing forest land. I think we're all definitely on the same page there.
Plant more. The trees are good. They're just they're not going to get us all the way there.
Yeah. All right. Are you long or short on a national carbon price by 2025? Jim, I'll start with you.
Short.
Freya. Sorry,
Oh,
you can defend if you want, but you don't
No,
have
no, I think we're going to be, I think at a national level, I don't think we're going to reach consensus by 2025, but I would be very long that by 2025, 75% of the United States is covered at the state and regional level by some sort of carbon pricing.
Wow, okay.
cool.
Yeah.
That's optimistic.
Yeah,
Well,
that's
look,
bold.
we go and we argue and we never get it right at the federal level, and everybody goes back to the states and experiments. I mean, Washington, Oregon, the Northeast would be
No,
nice.
I mean, you see the trend with the low carbon fuel standards. So
Yeah.
you know, I'm
I'm
gonna hang on to
very
that
optimistic.
optimism, Jim.
I'm optimistic.
I love it. But yes, short on 2025.
Deepika?
The same thing, you know, but can I also offer another perspective here? I would say 45Q really did something interesting in 2018. It put a price on carbon for the first time. I mean, we've had renewable energy tax credits and those kinds of things, but they were all for electricity production. They were not for removing or actually permanently sequestering a ton of CO2. So I would actually say 45Q kind of, you could consider that a price on carbon, a positive one, an incentive in that. So, so yeah, anyway, but no, I don't think that we're going to get a national carbon price by 2025.
Okay.
Sure.
Last two, and for this, I'm going to institute a no defense rule to keep it lightning fast. Deepika, we'll start with you. Are you long or short on the $100 per ton direct air capture?
Long.
Freya?
Long.
All right, Jim, I know you're long.
Super long.
All right, and the last one, geoengineering, not including CDR, other forms of geoengineering, long or short. Jim?
Ask David Keith. No, I think long.
Deepika?
Long.
Freya?
Yeah, I'm going with the group as well. Long.
Wow, controversial topic, but you know, definitely an interesting area, maybe one to explore in a future webinar. Susie, I will hand it back to you. Thank you everyone for joining us. Susie's going to lead audience Q&A.
Yeah, thanks. Great segue. You know, at some point, maybe that is a thought-provoking topic we'll have to explore. We're going to jump into audience Q&A in just a quick second. Don't worry, we're going to let you guys all out when the bell rings on time. Really quick, I want to do a poll with all of our attendees, just to understand if this is the type of content that you're liking from CET. You know, we would love to know what types of events are you interested in? You know, do you like these large events focused on specific sectors? Would you rather have more types of conversations, networking events, small group sessions, or other? You know, we'd love to hear from you. We're going to leave this open for 30 seconds. While we're doing that, you know, we received well over 2 pages of questions through the chat and Q&A from everybody. We're going to try to get to 1 question per speaker at the very least. And we're going to start that in just a second. I'm going to wait for a few more answers to come in on this poll. Okay. Thank you all. So the first question that I have is for Jim. Let's say we're able to repair the hole in Paul's boat. And we're able to just focus on, you know, what we currently have in the boat in terms of CO2. If all human caused CO2 emissions suddenly stopped, how long would it take for us to get to a more appropriate CO2 parts per million level with the current technologies that we have today?
So I think the question, well, I don't actually think from an engineering perspective there's any constraint whatsoever. I mean, if we had sort of unlimited money and everybody in the whole world, we just went full on Manhattan Project for the next, I mean, I think we could probably do it in 15 years. I think it's a question of how quickly will we coalesce around the capital markets and the policy and that sort of stuff. But the way I tend to think about it is, if you had to use DAC today, given what we know, we need 10,000 plants. if nobody else did anything else, right? If it was just on DAC's shoulders, that's a build rate that if you took that, I started off in the natural gas business, the big build rate in the 90s. If you got on the build rate of the natural gas build out globally that we had in the 90s, or the coal build out in the 50s and 60s, and we stayed on it for 20 years doing DAC plants, we could get there. I mean, so I actually think it's entirely doable, but it's gonna take decades. I mean, I think, and every year we wait is more that's up there, the more we got to catch up. So I would say that I think it probably takes probably does take us till 2050. And I mean, it's an entirely, I'll finish on this. Swiss Re did a really interesting study on it. And basically what they said was the carbon capture industry by mid-century will be the same market capitalization as the oil and gas industry is today, which is about a $15 trillion market cap. So I think it's going to take, to build that kind of market cap and that asset operating base, takes multi-decades, but it's entirely doable. I mean, I think a lot of people really worry that we can't. I don't worry at all about whether we can't. I only worry about the pace. Mm-hmm. So 20, 25 years, and I'll be 80, whatever.
Well, I mean, given that we're seeing all these 2050 targets, it's assuring to hear that you think that, you know, they're achievable. Means that we're working towards something, and that should be something that we should.
Well, the other thing, I don't want to take up all the time, but like, you know, we are living in a logarithmic world, right? Where the pace of change is moving on a log function, not on a linear function. And so when, you know, if it took 10 years to get a carbon price, if you think about the way the world works, it probably takes 5 years to really get going, and then 2 years and 1 year. So I actually think that we're moving on a non-linear pace in terms of innovation, which means that if we're saying 2050, we ought to be able to achieve it sooner.
Great. All right, I'm going to move on for time's sake. Thanks, Jim. Deepika, in terms of policy, what can states and regions do to encourage the development of carbon removal technologies? In 30 seconds.
Yeah, I'll just give an example. California, this is where I live. California has a transportation sector program called the Low Carbon Fuel Standard, which basically a market-based policy. If you're below the standard, you get to sell your credits. If you're above, you have to buy the credits. And direct air capture has been approved as one of the forms of generating credits, even if it doesn't have anything to do with fuels. So that's one example of leadership, I would say, that comes from climate ambition. So if regions have climate ambition, have great resources, such as what California has, although the direct air capture projects are not limited to California, California does have excellent geology to make a carbon sequestration industry work. So I think there's a lot of regions that can utilize local resources if they have a lot of CO2 industrial clusters. This is an opportunity to create, similar policies and set climate ambitions. I think that would be my answer.
Great, thank you. And the last question for Freya on cost. A couple folks were interested on how LanzaTech's fuels stacks up in terms of cost with fossil fuel. How do you see it, kind of reaching parity over time?
Sure. So we compare it to it's ethanol we make. So we're not running the cars on ethanol, but we use, and then for jet fuel, it's ethanol as a feedstock. So we compare it to first generation corn ethanol. The important thing is we're using waste. So we don't have the feedstock costs. So our cash cost of production is very low. And just sort of point to the reality of that, because people might be going, yeah, you would say that. We've got, our first plant running in China. A second one's just started up 2 weeks ago. A third one is in construction, all from the same customer. They would not be investing in these multi-million-dollar plants if the economics didn't stack up. And so that kind of speaks for itself.
Yeah, another assuring data point on the future of everything. So thank you. Once again, thank you to our speakers, Freya, Deepika, and Jim, for joining us this afternoon. We hope that everyone listening in enjoyed today's conversation. Our next conversation is scheduled for Tuesday, June 15th. We're going to be doing a deep dive on the evolution of community solar and what the latest and greatest in that market is. We hope you can join us. You'll be directed there to that registration page when you close out of Zoom today. Speakers from NG, Solstice, and American Families Impact Investing Fund will all be joining us for that event. So thank you for all being here today, and we look forward to seeing you again soon. Thanks very much.
Thank you.
Bye-bye.
Bye.